is Algebra exercise 41. So I need to prove that if R, the mapping of R to S is a ring homomorphism, then the kernel is an ideal of R. I think I'm going to call this phi. It might be psi, but I'm sure Nathan will cry quietly if I've got it wrong. So first thing I'm going to do is I'm going to at least try and show consistency in the symbol that I'm using, even if I'm calling it the wrong thing. So this is our ring R, this is our ring S, and we have a mapping between the two. This is our kernel. So the kernel of R is everything in R that maps to 0 in S. So in order to prove that anything is an ideal, there are 3 tests. So the first test is that it needs to be non-empty. Now, the thing we know about rings is they always have an additive identity in them, and that under a ring homomorphism, the additive identity maps to the additive identity. So basically, within this kernel here, we would have a 0R. Don't really have room to write it, but 0R, and this would be 0S. So this would be the additive identity of S. So effectively, that one is proven immediately just by the fact that it's a homomorphism. The second is to show that for all A and B in the kernel, A minus B exists within the kernel. Now, as the kernel is a subring, the existence of an additive inverse is inherited from the greater ring. So therefore, minus B does exist. So what we're basically saying is that if we've got phi of A plus phi of B, we know that that would map over to 0S, or would exist within 0S. And what we can say is, and that's for any A and B. So we know there exists a minus B. So we can say phi of A plus phi of minus B. That also equals phi of A minus B, as a ring homomorphism respects the properties of a ring, so the additive and the multiplicative. So, and we know that those two things, if they exist within the kernel, and we know they do because there is a minus B in the kernel, that will then map across, so that would exist within there as well. And finally, we need to show the slime monster principle. What is the slime monster principle, I hear you shout? Okay, so let's consider some element in S. We'll call it little s. So little s in S. Okay, now we choose little s such that phi of some element R equals S. So we're going to have some element R here that is not in the kernel. And what on earth is that? So what we want is so we're going to choose let A exist within the kernel and R in R. So we are going to show that AR and RA exist within the kernel. And this allows us to show slime monster principle. So what we're going to do is we're going to, and if they're in the kernel, we know that they're going to map to the 0 over here in S. So let's start off with AR. Okay. So if we do our mapping to AR, that's the same as the mapping on A multiplied by the mapping on R. Okay, now we know that A exists within the kernel. So what happens is this maps to 0s. And we've already defined this in such a way that this is little s. So this becomes 0 times little s, which is 0. So therefore, phi of AR exists within there, which implies that AR exists in the kernel. And similarly, we can show exactly the same thing for RA. So this becomes phi of R. This is phi of A. So this is S. And this is 0s. And then we can just follow it along. So we know that RA exists within the kernel. And we've now shown all three things hold. So just to be absolutely sure, there's the slime monster. So we have proven that Kerr of phi is an ideal in the ring R.